Hey guys, Mr. Lloyd here. Going to work with you on page 3 of 3 for Tuesday, April 14th. And this page has 6-2 remembering up top, and we'll just solve them all together. So problem 1 here gives us a little story. And what we'll do here is we'll take, it's asking us to compare tables to chairs. So tables and chairs are in a ratio. Lunchroom A and lunchroom B, different rooms, but they have the same ratio. So lunchroom A is given to us as 7 tables and 42 chairs. B gives us unknown number of tables and 54 chairs. And so the question is, what is that unknown? That's part of math. We're going to try to figure this out. My method for solving this was to turn it into a cross multiplication problem. 7 times 54 here and 42 times x. So we get 378 equals 42x. We divide by 42 to find out that x equals 9. You could have also divided 42 by 7, found that to be 6, and asked yourself what 54 divided by 6 equals what, and of course that would be 9. So lots of different ways we can solve these. I just like that cross multiplication approach. Numbers 2 through 4, we're just combining like terms. We're using that distributive property to combine like terms. And you'll see here on my paper, I have these little slashes. And remember in class, when I combine like terms, one of the things I always say is to cross out, once you've combined the like terms, cross them out so you don't accidentally combine them again. So 6t and 7t, I cross them out, I get 13t. TR is TR, I can't do anything with TR, and 4R and 4R, I can't do anything with 4R. Remember, like terms have the same variable. So here, 4R can only be combined with other R's, TR can only be combined with other TRs, and T can only be combined with other T's. So this is just one of those practice skills here. Once again, I did my distributive property and then combined it here for number 3, and did the same thing here for number 4, excuse me. Okay. Numbers 5 through 10, I'm just going to let you look here. We're just doing some operations with fractions. So here I'm writing equivalent fractions. 3 and 3/8 is this equivalent to 3 and 16/6, and 3 and 1/6 is equivalent to 3 and 2/12. Lots of different fractions that are equivalent to those two. I just chose those particular two. 3 and 3/8 is greater than 3 and 1/6. And then you can just see my work there. I'm just adding and subtracting, multiplying and dividing these two fractions. Remember, when you're adding and subtracting, you'll notice I converted each to 24ths. That's that common denominator. We always have to find a common denominator with fractions when we add and subtract. We don't need to worry about that when we multiply and divide. So take a second if you need to pause the video there to take a closer look. Feel free to do that. Let's come down to numbers 11 through 12. Number 11, I showed my work surface area. Remember, we're finding the surface of each of the rectangles that make up this cube, so the faces of each one. You can see my work there in pink. I multiply them together, and then I add them all up because we want the total surface area. So we add them all together. We get this number, 448. And then the volume here, remember, it's just found by multiplying length times width times height. I kind of showed you the length, height, and width. There you go, and we get 768. 12 and 13, I'm going to show you my work on the notebook paper that I did it on because it doesn't really fit on the worksheet there. So that's number 12. I wrote down my length, width, and height. I found my surface area to be 294, and my volume for number 12 to be 343. So again, if you need to pause it, feel free, but these are just measurements taken from the worksheet. Okay, number 13, same thing here. I've got this rectangle is 14 by 16 by 14 by 16 by 5, excuse me. And so I just take those measurements and I turn it into a surface area problem just like that. Okay, and there's my surface area, 748. There's my volume, length times width times height. All right, last problem here is going to be the big problem for the stretch your thinking. And this one, I'm just going to leave this up here. I wrote my thinking down on my paper, so I'm just going to leave this up here. And hopefully this is enough to figure this one out. This was a super tricky problem. Thank you for